Welcome back to All This Math. This is Professor Parker, and we're doing some Praxis prep. This is a sample problem from one of the Praxis prep workbooks that I use when I'm teaching a Praxis prep math course, right? And this is one of the problems that we went over in my Praxis prep math course this past weekend. So this problem says, what is the solution for the following equation? So basically, they're just trying to say solve, but this is another tactic that these test creators make in order to challenge you and try to throw you off your square, right? They make the question seem a lot more deeper than what it really is. They're basically just telling you to solve for x, right? But instead they're saying, what is the solution for the following equation, right? So they make it more verbose in an attempt to try to make you intimidated, but don't let these problems intimidate you. What I'm gonna do is, I'm gonna do this problem in two different ways. The first way I'm gonna do it the traditional way using algebra. All right, the traditional way using algebra, and then I'm gonna do it using the test taking strategy. Secondly, I'm gonna use a test taking strategy because you honestly might not know the algebra that's involved to solve for x, right? So here we go. All right, so I'm looking at this, and the equation is a rational equation. It says x squared plus x minus 30 divided by x minus 5 equals 11. Now I want to know what value of x makes this a true statement. So what number can I substitute for x and then carry out all the math, substitute for x here, here, and here, carry out all the math, and then it would be equal to 11. Now the way I do that algebraically is I want to basically simplify this numerator by factoring it. This is a quadratic trinomial, quadratic because of the exponent 2. It's a trinomial because it's got 3 terms, 1, 2, 3, right? Quadratic trinomial. So the way I can factor this is we break it down into 2 binomials. So a trinomial breaks down into 2 binomials. And the way we do it is this. So I'm going to draw an arrow, and I'm going to have x plus 6 times x minus 5. And I'm going to explain where I got this from momentarily, right? Over x minus 5 is equal to 11. Now, you should be wondering, where did this x plus 6 come from? Where did this x minus 5 come from? All right, there's a method that we use when we're factoring quadratic trinomials, and some people call it reverse FOIL, right? Because basically we're doing the opposite of the FOIL method. Now, the FOIL method is a method of multiplying binomials. This is a binomial because it has 2 terms. This is a binomial because it's got 2 terms. If we multiply this out in a certain way, x times negative 5, 6 times x, and 6 times negative 5, we call that the FOIL method because we did the first, which is your f, the outers, which is your O, the inners, which is your I, and the last terms, which is your L. Foil, right? Aluminum foil, right? It's like you wrap your plate up when you come from the cookout. You know what I'm saying? So, but when we factor it, we do the opposite of that because if we multiply this out, it would equal this, right? So basically to factor it, all you do is you set up 2 sets of parentheses, right? And I got a bunch of factoring videos on the channel in a playlist called Factoring Trinomials where a is equal to 1, right? And we would say a is the coefficient of x squared. So I got a bunch of videos like this. So if you want further support with how to factor quadratic trinomials, I got a bunch of videos on that, all right? So you can check those videos out too, right? But what we do is we say, okay, I'm gonna create 2 binomials. So I write the parentheses, and then I take the square root of x squared and I put it x and x, because x times x is x squared. And then what I do is I look for 2 factors of negative 30 that also add up to the coefficient of this term. 2 factors of negative 30 that add up to positive 1. So those factors are positive 6 and negative 5. Now, how do I know that? I just know it because I got a lot of experience with doing this method. And I know the factors of 30 that are going to work because the factors of 30 could be 30 and 1, could be 10 and 3, they could be 6 and 5, they could be 15 and 2. But it's like doing a puzzle because those 2 factors also have to add up to positive 1. So that's why we have positive 6 and negative 5, right? And negative 6 and positive 5 won't work because that would add up to negative 1. But we need the 2 factors that add up to positive 1, all right? So that's where the x plus 6 and the x minus 5 came from, right? Now, there's already an x minus 5 in the denominator, so I keep that. There's an 11 right here. So now I look for things I can cancel out. Now I got an x minus 5 up here, and x minus 5 down here. They cancel out and turn into 1s. So now I'm left with just x plus 6 is equal to 11. Now I got one step left, because when I solve or find the solution, we isolate the variable. We isolate the variable by itself. So that means we need to get rid of 6. So I have to ask myself, how am I going to get rid of 6? I get rid of 6 by subtracting 6 on both sides. So I'm going to do minus 6 on the left. I'm going to do minus 6 on the right. Boom, boom. X is equal to 5, right? But we always got to go back, because this is a rational equation, we got to make sure this is not extraneous, or what we call an extraneous solution, or an extra solution that don't really work for real, even though the math works out, but this in real life might not actually work. So if I plug this back in, and this is why it's highly recommended that you always check your work when you're doing algebra and solving equations, right? So I plug this in, 5 squared, that's 25, plus 5, that's 30. 30 minus 30 is 0. So the numerator is 0. Now, what's 5 minus 5? Also 0. 0 over 0 is not equal to 11. And 0 over 0 is not even a defined number. It's undefined because it has a 0 for the denominator. So even though our algebra worked out, even though our math is correct, our process is correct, but this happens sometimes. This is called an extraneous solution. It's like, when Dr. King talked about, answers that don't answer, the United States government coming through with answers for the black community. And they really are just answers that don't answer, explanations that don't explain, and solutions that don't solve. And then later on, Fred Hampton, a member of the Black Panther Party in Chicago, Illinois, who was assassinated later, he also said the same thing. He echoed the same sentiment and the same idea. So this happens in mathematics. So these real life issues can be reflected in mathematics, right? The same thing happens. So that tells us that there is no solution. There is no solution, right? Because we did the algebra and we came up with 5. But the solution we come up using algebra is no good. So therefore, there has to be no solution, right? Now, that's one way to do this problem. Another way to do this problem is to just simply back solve, right? Well, because this is a multiple choice question and we have 3 choices that we can test out, we want to see which one of these works, right? So what you do is, if you don't know the algebra and you don't know how to factor quadratic trinomials, and you're not as familiar or you're not as comfortable with using the algebraic methods, you can just back solve. And this is a test taking strategy. All right? So that's going to look like this. So check this out. If I want to test out choice A, I go into the equation and I replace the x's with -6, right? Any x I see. So right here, and right here. I replace them with -6s, and then I just do the calculations. So I'm going to have -6 in parentheses squared plus -6 in parentheses minus 30 over -6 minus 5 is equal to 11. Right? Now I want to do this work. So -6 squared is not -36. It's positive 36. So -6 squared is positive 36. Positive 36 plus -6. When you add a negative, that's the same thing as doing regular subtraction. Adding a negative is the same thing as doing regular subtraction. So 36 take away 6 is 30. 30 minus 30 is going to be 0. So my numerator gives me 0. And then -6 minus 5 gives me -11, right? Not -1, not +1, not none of that. It's -11. 0 divided by -11 is just 0. So once you get a 0 for your numerator, you know that your answer, you know that this left side is not going to equal to 11 because you got a 0 for your numerator. So I really didn't even have to calculate the denominator and do the -6 minus 5. I didn't even have to do all that because I already knew my numerator was 0. So that means that A is no good. So the solution can't be -6 because I just tested it. I plugged -6 in and I seen what happened. So now I'm going to skip B because I can't really plug in no solution, right? 16. I can plug in 16. So for 16, what I'll do is I'll just replace the X. I'll do the same thing I did when I plugged in -6, right? So I got -16 squared plus 16. Oh, that's a mistake. This is a positive 16. So why do I have a -16 right here? I'm tripping. My fault. All right, so 16. That should be 16 squared plus 16 minus 30 divided by 16 minus 5. Notice all I did is wherever I see an X at, I replace it with a 16. That's all I do. So I got 16 squared, I got 16, and I got 16, right? And that's equal to 11. So 16 squared is 256 plus 16 minus 30. 256 plus 16, I can add 10 to that. That's going to be 266. Plus the other 6 is going to be 272. Then 272 take away 30 is going to be 242. And the denominator, 16 minus 5, is going to be 11. So 242 divided by 11, I know that that's not equal to 11, right? I know it's not equal to 11. I know for a fact that 121 divided by 11 equals 11. So therefore, 242 divided by 11 definitely don't equal 11. All right? So that's no good, just like this was no good. So C is no good. Now, last but not least, I'm going to try 5, right? Now, I actually don't have to try 5 because we actually solved this algebraically and came up with x equals 5 as our solution. But then we tested it out and we saw that it gave us a solution that did not solve, right? Or it proved to be an extraneous solution. But I'm gonna just do it regardless because we're gonna act like we didn't even use the algebraic method, right? So let's replace the x's with 5s. So we got 5 squared plus 5 minus 30 divided by 5 minus 5. So we already know it's a problem. We know it's a problem right there because 5 minus 5, right? Matter of fact, I'm not even going to simplify the numerator. I'm going to just look at the denominator because I know for a fact, this is a mathematical rule, that we can never have denominators that are 0. We just can't have that. We can't have denominators that are 0. So 5 minus 5 is 0, so that's already undefined. And 11 is defined, so therefore D is no good. So therefore, that's why there's no solution to this equation. There's no solution. This is answer choice B. So if you don't really know the algebra or you're not as comfortable with the algebra, then use this method. Just back solve. And this is the same method that students use when they're taking the SAT or the ACT or really with any standardized test where there are, challenging problems and they're multiple choice, right? Sometimes you can just back solve and just figure things out. All right. So I showed you how to do it algebraically. Like I said, if you want to learn how to do it algebraically by factoring quadratic trinomial expressions, it sounds difficult, but it's not as difficult as it sounds. I promise you. A lot of stuff in math sounds real hard, but when you learn how to do it, you're like, oh, that's all you really got to do? A lot of math is like that. Trust me, right? I do have other videos on the channel. There's a playlist entitled Factoring Quadratic Trinomials where A equals 1. And when I say A, we're talking about the coefficient of the x squared term. And since there's no number written here, we know that that A is equal to a positive 1. Whenever there's no number written, it's understood to be a positive 1. Just like with exponents. When there's no exponent written, it's understood to be a positive 1. Same concept, right? Or with a fraction. If you got a whole number and it doesn't have a denominator, if you did write it as a fraction, your denominator would be a 1, basically. All right, so that's that. Now it's time for you to go practice because that's how you really learn and that's how you're really going to prepare for this test, by practicing. It's all about practice until you become comfortable and you develop a muscle memory for this. All right, so you go practice and I'll check you out on the next video. Peace.